Light is a radiant energy. The ultimate source of light energy is the sun. Sunlight is less absorbed in aquatic system at a lower angle like 1 to 45 degrees. Absorption and penetration of light rays to the deeper zone is attained at higher degree or angle like 70 to 90 degrees. At lower angle, more light rays are scattered or diffused and subsequently reflected to the atmosphere. And this is the reason why in the later part of March up to the early part of November in the Philippines. When more light is absorbed, the natural bodies of water are warmer and production of phytoplankton and other kinds of algae are far better than during colder period, from late November up to the early part of March, when light energy is less absorbed and scattered. The relation of light absorption to application of inorganic or chemical fertilizer is that phytoplankton quickly responds to fertilization at greater absorption of light energy. Supplies energy necessary for primary productivity. Production of all kinds of plants, except fungi, for food of animal organisms. The process involved in primary productivity is known as photosynthesis. Illuminates dark water for the aquatic animals to see their foods. Determines the kinds and amounts of food available for fish. For coloration of the body of the aquatic animals and triggers and directs movements of aquatic animals. Turbidity is the degree by which transparency of water is reduced by dissolved substances, suspended, solids, and plankton. However, if turbidity is referred to as the abundance of plankton production, then the distance of the visibility of second disk multiplied by 2 is equal to the depth of the euphotic zone, the production zone. In fish pond, the depth of measurement or thickness of euphotic zone is usually less than 1 meter. Dissolved oxygen is the gas of greatest importance in fish culture. It is a highly critical water quality parameter in fish culture. It is important for the fish culturist to fully acquaint himself with the dynamics of dissolved oxygen concentrations in pond, lakes, and other aquaculture systems, including tanks of different types. Uses of dissolved oxygen in aquaculture. It is used for respiration. It helps in feed consumption, digestion, and assimilation. It maintains osmotic balance of fish. It helps in fish activities such as swimming, searching of food, and it helps in the oxidation of metabolites in the aquatic environment such as the ammonia and hydrogen sulfide into usable from nitrate and sulfate respectively. Dissolved oxygen in the water can be expressed in 2 ways: absolute concentration or relative concentration, and measured by titration using Winkler method, by electronic instrument, yellow spring instrument, or by reagent chemical substance with the use of Hatch kit. Ideal or desirable range of dissolved oxygen level for fin fishes and crustaceans is 6 to 8 parts per million, although 5 mg is satisfactory. Reduced food consumption by fish occurs at dissolved oxygen concentration near 4 mg. If dissolved oxygen concentration remains at less than 3 or 4 mg per prolonged period, fish cease to feed and growth is impaired.